Welcome to Tuesday's lesson. Before we begin, let's talk about the homework assignments for tonight. You're going to have two IXLs right here. We have AL.S.3 and AL.S.4. Again, as always, we're going to do an 85 SMART score. Okay, so make sure you get a SMART score of 85 or higher. Okay, today we're talking about a new term, the term slope, and how it's related to rate of change. Okay, so describe what's happening at each interval. Here we have a graph, and let me actually try to zoom out just a little bit so we can see. And in this graph, we have speed is the y-axis, and the x-axis is time. So, from A to B, the speed is going up from 0 to 50 miles per hour, and it's taking 10 seconds. So the speed of, I'm guessing this is a car. I don't think it's a person running, but it could be any type of really vehicle or it's anything like that. It's going from 0 to 50 miles per hour in 10 seconds. Now, from B to C, right here, we notice that it's not that the car is not moving, even though it's flat, it's staying at 50 miles per hour. So in this case, from B to C, I'm going to call it a car. The car is moving at a constant rate of 50 miles per hour. Then from C to D, we see the speed goes down, okay? So the car is slowing down from C to D. From D to E, the car is speeding back up, but not to the same speed as it started. And then from E to F, the car slows down to the point where it actually reaches 0 miles per hour. So eventually it comes to a stop. Okay? Anytime you're trying to read a graph and describe what's happening, you have to first look at what your axes are, okay? In this case, we're talking about speed and time. If we were talking about, if this were distance instead of speed, then here the distance wouldn't be changing, and therefore whatever you were talking about would be at a stop. Because we're talking about speed, the fact that it's not changing means we're keeping the same speed. So it's really important that you understand what your axes are as you're describing an event that's happening. All right, now we're going to take the same graph, except we're going to try to find the interval in which the speed is changing the quickest. Now, I didn't want to say the most because the speed is changing the most in that interval, but we're saying the quickest. So it's a difference here in which the speed is changing the quickest. So from here to here, clearly the speed is changing the most. From A to B, I'm actually going to change that because I'm realizing now, depending on what you're watching this on, you might not see it. So from A to B, the speed is increasing 50 miles per hour, but it's taking 10 seconds. So we can look at 50 miles per hour in 10 seconds, and we could say, well, that is 5 miles per hour every second, right? So we could write that as 5 miles per hour per second, or we could say 5 miles per hour every second. Now from B to C, that's this one right here, it's changing 0 miles per hour in 15 seconds. But it doesn't matter if it were 30 seconds or 2 seconds, 0 miles per hour in 15 seconds is 0 miles per hour per second. From C to D, which is this interval right here, we're actually going from 50 down to 20, so we're going down 30 miles per hour, and it's taking us from 25 to 30 seconds, so it's taking us 5 seconds to do. That means that this is a deceleration of 6 miles per hour per second. All right, from D to E, we're going from 20 to 30, so 10 miles per hour in 15 seconds. 10 miles per hour in 15 seconds is 10 over 15, which is 0.666 repeating, or 2/3 miles per hour per second. And then finally, E to F, we're going from 30 down to 0, so we've gone down 30 miles per hour in 5 seconds. That should look familiar, because here we have, again, negative 6 miles per hour, or a deceleration of 6 miles per hour per second. So it's actually C, D, and E, F have the quickest changes in speed, okay? Even though this A, B looks like it's the one, it's not, okay? It's close at 5 miles per It's close at 5 miles per hour per second, but the negative 6 miles per hour, and remember, negative 6 miles per hour in this case is really just talking about a slowing down 6 miles per hour, okay? All right, well, these are all rates of change, okay? And we're going to talk about something similar to a rate of change today. We're going to talk about something called slope, okay? And a slope is a linear rate of change, meaning that it forms a straight line, okay? And in everything that we were talking about before, we were talking about how the y-axis changed compared to the x-axis. All right, so today we're talking about the slope of a line, and I'm going to talk briefly about, here we see this wakeboard ramp, okay? And as you can build the ramp at different angles, obviously the best angle is going to give you the best jump. It looks like he got a pretty good jump there based on this ramp. So it says the slope of a line. How steep is a wakeboard ramp like the one shown? To find out, you can calculate the ramp's slope. The slope of a line is the ratio of the line's vertical change, called the rise, to its horizontal change, called the run. If we talk about vertical change, we're talking about going up and down. You notice how on the graph before we talked about how the miles per hour went up or down, and then the horizontal change, we're talking about going left and right, and that's how, when we talked about how much time it was taking to make that change, okay? So those were all slopes we were calculating between different points. So if this wakeboard ramp has a rise of 6 feet and a run of 10 feet, we can find its slope. So slope is rise over run, which in this ramp's case, it rises 6 feet, and run, or its horizontal change, is 10 feet, and we can write that as a ratio, and we're going to then reduce that ratio. 6 over 10 equals 3 over 5. So we can leave it just as a fraction, and you're going to see that it's much more helpful to have as a fraction. And in fact, slopes, when we have them as fractions, even improper fractions, we would just reduce it and leave it as an improper fraction most of the time. So you could just leave it like, if you had something like 8 over 3, instead of making it 2 2/3, you just write it as 8 over 3, okay? To determine the slope of a line in a coordinate plane, you can find the ratio of the vertical change between 2 points on the line and the horizontal change between 2 points. So here we have the point 3, 1 and 5, 4. I don't like how they wrote it in that order, because we're going to do rise over run. So why did they do run over rise? Why did they do the run first? I don't know, okay? But if I'm going from this point to this point, I'm going to go up 1, 2, 3. So the rise is up 3, and the run, 1, 2, is a positive 2. Now, you notice I wrote it as a positive 2 because anytime you move this way on a number line, it's positive. Anytime you move this way on the y-axis, it is positive. Okay? Now, the reason why I'm telling you that is because what if, you notice how I didn't tell you what order you had to do the rise over run. So what if, instead of going from this point, 3, 1, instead of going from 3, 1 to 5, 4, what if instead we looked at going from 5, 4 down to 3, 1? So in this case, the rise would be 1, 2, 3, but we'd be going down 3. But the run would be going to the left 1, 2. And anytime you make a movement to the left on a number line, that's a negative. Well, what do we get when you have negative 3 over negative 2? A negative over a negative is positive, and we have 3, 2. What do we have here? Positive over positive, which is a positive 3, 2. It's the same thing. So it doesn't matter which point you start at, because it's all about your direction. If you're moving up, it's positive, down is negative. Left is negative, right is positive. Okay? It's all about direction when it comes to slope. Now, we have 4 different types of slopes. A positive slope, and this would be a good thing for your notes, a positive slope, as we read it from left to right, it goes up. Okay, that's a positive slope. A negative slope from left to right goes down or falls. Then we have a zero slope, which is when the car was not gaining any speed. It was sitting there. It's a flat horizontal line, a zero slope. And then finally, when we have a straight up or down line, we have what's called as an undefined slope. And we're going to get more into an undefined slope later on, but it is important to understand that, remember, anytime we have 2 lines that touch like that, it's not a function. So that's going to be important, and we're going to go over that more tomorrow in tomorrow's lesson. Okay? So, finally, let's practice finding the slope between these 2 points. So, again, remember, it doesn't matter which order you go in, okay? So I'm going to go, for this one, I'm going to go from here, 0, 3 to 6, 5. So, in order to do that, I'm going to go up 2, and I'm going to go over 1, 2, 3, 4, 5, 6. So that's 2 over 6, which is 1 over 3. Now, we don't even have to know that it's positive as far as up and over, because if we look at this line, it fits the definition of a positive slope. Okay? Just like number 2 fits the definition of a negative slope, we know it's negative before we even do it. And again, doesn't matter where we start. I'm going to start here and end here. So the rise is 1, 2, 3, 4. It's a negative 4 because we're going down 4 and over 2. And this over is a positive because we're moving to the right. Negative 4 over 2 equals negative 2. You can write it as negative 2 or negative 2 over 1. That is up to you. If we had gone from this point to this point, we would have gone up 1, 2, 3, 4. So that would have been positive, but then we would have had to go to the left 1, 2, which would have been negative, and guess what 4 over negative 2 is? Negative 2 also, okay? So it doesn't matter which point you start at and which you end at, as long as you're keeping track of your direction, up positive, down negative, right positive, left negative, and that's how you do slope. All right? Good luck on the IXLs. Let me know if you have any questions. I'll see you guys tomorrow.